Hey guys, today we're going to talk about the Zerologon exploit for Windows Active Directory. I'll be demonstrating the exploit on a server 2012 using a Kali box to exploit it, both of which are spun up on my local ESXi. Alright, let's get into it. So, to start off, we need to get some more information on our domain controller. I already know the exact address of it, that .43, so this is a little easier for me, but if you don't know the address of your domain controller that you're going to be targeting, you will need to figure that out. You can do some subnet scans, you can do whatever you need to do to get that address. And it does take a little bit of time to get this Nmap scan done, so I'm going to skip ahead to when it's finished. Alright, we've got our Nmap scan completed here, and as we can see, we're seeing the typical services for a domain controller right here, and we can see that the host name here is demo442vm, and that the domain name is demo442.com. Both of those we're going to need later to do this exploit. Now, the next step before we can start the exploit process is we need to change our DNS to the DNS on the Active Directory server, and this is so that we can actually communicate using that domain name. Otherwise, if we're not on the same DNS, it's not forwarding, we can't actually, use the exploit to send information. So what we're going to do for that is we're going to open the DHCP client configuration, and that's right over in here. And we're going to go ahead and change this prepend domain name servers to the address of that DNS server, which in this case is also the Active Directory. So 192.168.10.43. We're going to save that. And then we're going to come here and we're going to also make those changes to resolve.conf. And let's open that up. Oops. There we go. And we're going to change that here as well. Let's save that. Or not save that, because we need to actually sudo this. There we go. Now we'll be able to change that. 168.10.43, the address of our domain controller. I'm going to save that. It's going to actually save this time. And then we're just going to change those permissions again. I can't even type today. There we go. And we're going to restart our network manager. There we go. Enter our password, which hopefully we put in right. Oops. Using a keyboard I don't normally use. It's kind of spaced a little differently. All right, and now that we've got that going, our DNS is the Active Directory domain controller. We can actually start our exploit. And I've already gone ahead and done this as a prereq, but you will need to download both Impacket and Zerologon. The links will be in the description for both of those if you need them. Zerologon, of course, is going to be the exploit scripts we're going to use, and they're reliant on Impacket, which is very well known, very used Python library and tools for wireless attacks. So we'll be using both of those. And we want to start off by getting into this Zerologon folder. And we are going to use this first here, this set empty password. And we'll discuss later in the presentation more on the technical details of what's going on, but this is essentially going to force the machine password on the Active Directory domain controller to an empty string, which is the first necessary step for actually getting in and pulling out credentials. So what we're going to do here is we're going to do Python 3 set empty password, and we're going to use that host name right here, that machine name, and then the address, and that's all we're going to do. And we're going to let that script run its magic here, and this is where it's brute forcing that authentication, and we'll talk more about that later, really dive deep into that. And the way the exploit works, 1 in 256 attempts is guaranteed to work. It's guaranteed to get you in. And as we can see, that's what happened. So right now, the machine password is an empty string on that domain controller. And the password in the registry hasn't changed. That registry value is still there, but the password it's going to be authenticating with is this empty string. And this does break a lot of domain controller functions, and at the end of the exploit process, we will go back and change that back so that the directory administrators can't actually tell that we've done anything. It's actually rather neat how that all works out. And now we are going to, for our next step, go back up, and we're going to go into Impacket, and we're going to look at some of their examples here, and use one of their example scripts called secrets dump. And so what we're going to want to do here with secrets dump is we don't want to do that SAM stuff. We are going to do secrets dump dash hashes, and we're going to use this hash right here. And this hash right here is for that empty password that we just set. So this will be the same every time for this first secrets dump step. And right here we've got our domain and our machine and the address that we're going to, that the domain controller is on. And we're going to let that run. And we're going to forget to sudo that. There we go. Now we're going to let that run. And as you can see, we've gone in and we now have the administrator hash, guest hash, KRBTGT hash. We've got all of that. And of course, the actual machine hash too, which you can see this right here matches that because that's the empty string that we've set. And now that we've got this information, this is where we can really start to heat things up. What we're going to do is we're going to copy out this administrator hash right here. And we're just going to copy that selection right to our clipboard here. And we're going to use this tool here called WMI exec. And what we're going to do here is we're going to create an SMB connection as administrator to that domain controller using that administrator hash that we got right here. Right? So all we're doing here is, login authentication. This is the domain, this is the user, and then this is the address of the machine, right? And then, of course, the password hash. And so we're going to run that. And now we've got an SMB connection, and we can now actually pull out those registry keys for the credentials that we're going to need. So all we're going to do here is regsave HKLM, and we're going to pull out system, and we're just going to save that as system.save. And that's going to complete. And then we're going to do the same thing for the SAM. There we go. And forgive me, the VM is a little slow. And we're going to do the same thing, for security, all caps. And then we're going to take those saves and we're going to pull them off and bring them to our machine over here. And just to do that, we're just going to lget system.save. Let's pull that out. We're going to lget sam.save. It's going to pull that out, and we're going to lget security.save. And then to obscure our intrusion here, we're going to delete those two. We're going to forcibly delete those saves that we made so that there's no record that we've been in here. And get rid of that security.save as well. There we go. And that's all we're doing. That's all we need to do. We're going to pull out of there now. And now we're going to go back to using that secrets dump. And so for that secrets dump, now we can actually use -sam save -system save. We're using those files that we just pulled out, right? And now we've pulled out the hashes that we already got here, and the plain password hex here, machine passwords. We've got all of this information. We can pass these through, John the Ripper hashcat. We can use these for golden ticket attacks. You can do whatever you want, right? We've compromised the domain controller, and we've got all the information that we could ever need to gain access to it. And it's as easy as running, 3 different commands, secrets dump, wmi exec, and set empty password. Very simple, very easy to do. That's obviously why it was such a dangerous exploit when it was running wild. And then, to wrap it all up, we've left some traces here, right? That machine password is still an empty string. They can go in. Some parts of that domain controller functionality aren't going to be working anymore because of that password change. And so we want to kind of cover our steps and be a little sneaky in our approach on stealing all of this information, exfiltrating this information. So to cover our tracks, we're actually going to go back into that Zerologon folder here. If we can actually type today. There we go. And we're going to use this little script right here, reinstall original password. And what this is going to do is it's going to change that machine password from that blank password, that empty string password, to its actual password that's in the registry, and that's this value up here that we've gotten from that secrets dump. And we're just going to copy that. So there we go. We're going to copy that selection, and all we're going to do is reinstall original password. Oops, got a little too carried away there. Reinstall original password. And we're going to put in the hostname here, which was demo442 VM. And we're going to put in our IP address here, which is 192.168.10.43. And then we're going to put in our hash. And we forgot to run that through Python. There we go. And now we can see that it's authenticated. It's reset that back to its original password that's in the registry. And we can secrets dump that again to check and make sure that everything's correct. In the real world, you'd probably want to do that and make sure that you've set that back and covered your tracks. In our little demo, I'm not too worried about it. This 2012 server is just going to get reset anyways in a hot second. So it's not too much to worry about. And so we're just going to get rid of all this. And now I'm going to demonstrate, the easy fix here for preventing this from happening to you. And really all that's going to be is, if we can revert back to demo start. And we're just reverting on the off chance that that machine password reset didn't work. This is just I guess, extra backup in case that script didn't actually reset the machine password correctly. Because if it didn't, your domain controller is going to have some problems. So we'll give that a second to reboot. There we go. All right, now we're back into it. And all we're going to do is just download the Microsoft patch. It's KB4601357. Again, link will be in the description below. And I'll show you once you get this installed, which is, very easy. You just run the installer. We'll try to redo that exploit, and, it won't work, and we'll see what happens and everything. So while this is installing, we're going to come back in here and make sure that we are in the right thing. We are. And we're just going to prep that set empty password again so that we can run that right when that's finished. All right. And we're using the same exact setup that we did the first time. This is just going to be post-patch. All right. All right, we've installed that update and restarted. So we're going to sign back in here. And we're going to get that up and running and make sure that our services are golden. And it is a little slow. We are running a lot of stuff on this little EXSI. All right. And it looks like it's booting up just fine. I always like to double check that my services are good. All right, and we're good here. We got AD up and running and DNS up and running. So we are good to test this out again. So again, running exactly the same thing that we did the first time. But this time now our 2012 server has been patched. And so let's see if this actually works. It's going to try to authenticate. And I believe this particular script tries 2,000 times. And you should only need to try 256 times. Because if you are unpatched, it is guaranteed to work 1 in 256 times. But the script runs 2,000 times just for redundancy in case there's, false negatives, false, whatever. So we're just going to keep letting this run. And as you can see, it's not actually, compromising our machine, right? It's being blocked at that login. So I would say this pretty much goes to show that our patching works. So, there you have it. All you got to do to solve the Zerologon issue, download that Microsoft patch, and as you see, yep, the attack failed. Target is probably patched. So it's as easy as that. Very, very critical vulnerability in Windows. And if you haven't patched that, you absolutely should. And we'll just take a look here. And it is, oops, again with the typing, not my forte. Here we go, right here. That's that hotfix ID. Again, I will have a link for that in the description. If you haven't downloaded that and installed that yet, you really should consider doing so. And then I guess let's just jump into a little breakdown on some of that more technical detail that I was talking about on what's actually happening during this exploit and what those scripts are actually doing. All right, and here is a brief overview of sort of the more technical details and aspects of that exploit that we just demonstrated. Essentially, what's happening is the net logon credential has a 8-byte challenge as input and an 8-byte challenge, or 8-byte result of that cryptographic exchange. And the newer version of that AES CFB8, which is also the only one that's allowed in some of the newer Windows versions, starts with a random initialization vector of 16 bytes. And when you're using an 8-byte encryption, that means that it is possible for 8 bytes of zeros to yield a ciphertext of zeros with a probability of 1 in 256. So it means, 1 out of every 256, random initialization vectors is going to be 8 bytes of zeros. And, that in of itself is a big cryptographic flaw that you can, sort of predict that's going to happen every single time. 1 out of every 256 attempts is going to end up with that result. But that isn't so much of a problem by itself until we combine that with another flaw in Netrogon, which is by default, unencrypted sessions are not rejected by the server, which means that you can just keep trying over and over and over and over again, and eventually you are guaranteed to get in with that, empty string, right? And so that's why when we're actually doing that exploit, we've got our, first step here is brute forcing that 8-byte cipher, right? So we can guarantee that on an unpatched system, it's going to work 1 in 256 times every time, right? So if we just attempt that 256 times, it's going to work every single time. And as we can see in our script that we were running, the first time it ran, it ran for a couple of seconds and boom, it got in, right? And then when we patched, it ran and it took much longer because it was trying that script runs 2,000 times and you really only need to run 256 times. But it's the same idea where, it ran through, got in within those 256 tries, and you're guaranteed to have that work every single time, right? And then, of course, that set empty password script also did that second step here, set empty password, which just uses the netar server password set call to change that machine password to an empty string, right? It spoofs, the identity of the domain controller, and it tells the domain controller to set the machine password to blank. And of course, that's just a string of zeros, an empty string. And of course, when your machine password and your registry, the password stored in the registry aren't the same, that causes some issues. And so it does break your domain controller functionality for the period of time that password is an empty string, which is why we revert that back when we're done, because we don't want those administrators to know that we've been in, right? They'll just see that as a blip in their system if they're even monitoring for that, right? And we know a lot of administrators aren't staring at those event logs every single day. So once we've gotten in and we've done that brute force, we've done that password change, now we can actually get in and start dumping those hashes. And that's what we were doing with that WMI exec script and secrets dump. We were going in, we were getting hashes, and we were pulling, all the information we wanted out of that domain controller so that we could use that later on, if we were a cyber criminal. And so, we did that through registry connection. You also do it through domain replication. You've got that password. You can get in and do that however you'd like. And then, of course, our final step was detection avoidance, setting that password back to what it was so that functionality is restored and that our intrusion and exfiltration remains unnoticed. Because, the last thing we want is for the defenders, the administrators, to notice that we've actually been in there and taken all of their stuff. Because that would really put a damper on trying to use those hashes, use that information later on. And of course, you can use those hashes for golden ticket attacks, pass a hash attack, silver ticket attacks. You can use that information however you like those hashes. And then I've got this nice little image that I've appropriated from CrowdStrike down here. Thank you, CrowdStrike. That just kind of walks through that process, right? So, our first thing we did was we brute forced that cryptographic exchange. And of course, because it's an unpatched system we were targeting, we got a successful response and we were able to change that password, right? And then once we changed that password down here, right, perform domain replication using empty password, we were able to dump those secrets. In this case, all those hashes. And then when we finished, we popped that machine password back to what it was, that original registry value. And now, if we were a cyber criminal, we were trying to steal information or do something, spooky, that's the step we're on now, where we can exploit those secrets. We can go into any domain machine. We can do whatever we want in that domain because we've stolen all that information. And the exploit itself takes 5-6 minutes. It's so easy to do, which is why it's so important to patch it, to mitigate it, and to take steps preventing that from happening to your devices. And obviously installing that security patch from Microsoft is the easiest, fastest, and most guaranteed way to fix this. Microsoft's done all the heavy lifting. They figured it all out. All you got to do is install it. Very quick, easy install, and you're safe. You're good to go. In the event that you are compromised, however, you have noticed this has happened to you, you can see, you can do some zero trust, MFA, you can do anything that will prevent movement within your domain will help you here, as long as those secrets are not stolen as well. And of course, even with the patch, you should still be monitoring these attempts. You should be going through your event logs, looking at those logins, looking at those connections, seeing what's going on, making sure that nobody's tried to do this to you or nobody has done this to you, because it is very, very bad, and you can pull everything out of it very, very easily. And that's all I had for today. Thank you for watching. Again, links to everything I talked about will be below. That in-packet, Zerologon scripts, and the patch. I'll also have a link to a little blog article kind of walking through these steps with code images and everything, so you can follow along with the video and the blog article. You should be able to replicate this in your own environment. I do need to say that this is, of course, research purposes only. Do not attempt to do this in the real world. Don't go out attacking other people's domains. That is illegal. You will go to jail. We can do this because it's in our own test environments, on our own network, our own machines. We've got permission to do it, and that is the most important thing. Don't go out and try to hack anybody just because you want to test out that new fandangled exploit that you saw on YouTube. And with that, have a good day.